This is an introduction to DOE, Default, Obscured, and Hidden Content. This course will introduce you to Default, Obscured, and Hidden Content, or DOE. This course is intended for developers, testers, and systems administrators. At the end of the course, you will be familiar with the risks associated with DOE, and you will have a basic understanding of effective methods to detect and mitigate those risks. We will begin by describing common problem scenarios encountered with DOE. Then we will define types of default, obscure, and hidden content. We will discuss associated risks and describe some common instances. Next, we will talk about ways DOE is created in deliverables and specific mitigations for those. Finally, we will wrap things up with tips on how to detect default, obscure, and hidden content. Let's start by talking about some common problems caused by DOE. Later, we will come back and cover exactly what these problems mean, what the risks are, and how to detect and mitigate them. But for now, let's begin by describing some scenarios we must try to avoid. Iteration. A user navigates a web application and comes across a link with a page script in the URL /getfile.php ID equals 354. The user iterates the ID parameter, for example, from 354 to 500, and accesses other files containing personal information belonging to other users. Default credentials. An IT administrator uses the default username and password to access a remote server. The administrator does not change the username or password after the initial login. The default credentials are common knowledge and are used by others to gain unauthorized access to the server. Backdoors. A developer creates an alternate login for a desktop application. The alternate login grants privileged access to advanced settings and for debugging. The application is released with the prompt visible to the user. The prompt reveals the instruction: to log in, click the bottom right area of the application window while holding the Control key. A user enables debugging. This exposes database credentials, application logic, and queries. Housekeeping. A factory worker is performing routine maintenance on a product computer. He selects Show Hidden Files and Folders and finds source code files left behind. The source code is posted to an internet chat forum and exploits are crafted. All the problems described consist of source code, configuration files, documentation, or URL breadcrumbs that were left behind unintentionally or were inadvertently made accessible to users. The resulting system vulnerabilities allow exploitation, which may impact privacy, system performance, and/or system operation. DOE content permits hackers to obtain restricted URLs, credentials, execution logic, and general information. So what exactly is content that is default, obscure, and hidden? Let's start with what we mean when we say content. Content may be files, executable files, configuration files, source code, or documentation. Paths, web URLs, database server addresses, or file locations. Or software, scripts, services, and ports. When we talk about default content, this means content that is made available prior to or during the installation, or content that is made available during or at the completion of configuration. When we say obscure, we mean content that is unknown or secret, and content that is difficult to understand. And finally, when we say hidden, we are describing content that is not intended to be openly accessible or available, and content that is not intended for regular use. Let's review the risks associated with DOE content. Unauthorized access. This is the risk a user will be able to view or obtain information or resources without proper permission. For example, connecting to and querying a database for user account information is unauthorized access. Inappropriate usage. This is the risk a user may handle or consume content or resources for which they do not have permission. An example of inappropriate usage is storing music and movies on a customer documentation file server. Malicious code. Malicious code is any code that, upon execution, may cause harm to a system. For example, an application script file could be modified to embed malicious code to send data to a remote server. Denial of service. This is the risk that system resources may be made unavailable. Saving files to a server until the hard drive is full is an example of a denial of service attack. Data loss means the destruction of information in a system. For example, deleting a hidden system file may cause indexed data to become inaccessible. Data theft. Data theft is stealing information from a system. An example would be source code files left on a delivered system, copied and sold to a competitor. And finally, data modification, or in other words, allowing information in a system to be altered. For example, logging into a financial system database using default credentials and changing interest rates. All the risks described are present with DOE content, content that is default, obscured, or hidden. To make the connection, let's go back to the problem scenarios described earlier. First, let's consider the problem of the factory worker performing routine maintenance on a product computer. He selects Show Hidden Files and Folders and finds source code files left behind. The risks in this scenario are unauthorized access. The source code could expose methods of accessing restricted locations. Data theft. The source code itself is data that can be stolen. And malicious code. Execution logic that is exposed can be used to inject malicious code. Next, a developer leaves an alternate login prompt, granting access to advanced settings and debugging tools on a delivered desktop application. The risks here are unauthorized access. The login is not intended for typical users. Inappropriate usage. Debugging is not an end-user feature. And data theft, loss, or modification. The user may gain elevated access to data. The next problem. A user is navigating a web application and comes across a link with a page script in the URL /getfile.php ID equals 354. The user iterates the URL from 354 to 500 and is able to view content not intended for his use. The risks are unauthorized access, because these files are not intended for this user to access, and data theft. The user can download and share the file contents with others. And the last problem. An IT administrator logs into a remote access server using the default username and password and does not change them. All risks are present here: unauthorized access, inappropriate usage, data theft, data loss, data modification, and denial of service. Once logged into a system, a user may have full access. Let's review some specific examples of default content. Default content includes things like manuals or documentation provided with software, system management components installed with web servers, sample and test code installed with third-party software to facilitate initial setup, use, and customization, user interface components for installing and starting up system software, and credentials that are used for software initial configuration. Examples of obscure and hidden content include things like configuration files, obfuscating directories with foo, or obfuscating revision control files and folders, renaming previous versions of files, or adding extensions, .back, .old, or .orig, displaying paths, file names, and indexed parameters that can be iterated or guessed, such as a PHP script with an ID parameter, displaying paths and file names that can be traversed to expose additional content, like a system folder named promotions/June. Someone curious might try promotions/July. Error messages with code comments that expose exploitable system logic, and system modes that expose logic, such as the hidden HTML tag for passing information in web pages. Now that we know what DOE is and what risks it brings, let's turn our attention to ways we create DOE and recommended mitigations. We'll use some examples to illustrate. Revision control is an essential component of system development. Unfortunately, artifacts of revision control can easily be left on a system delivered to a customer. One place we see elements of revision control left on systems is in web development, following synchronization of server code in a production environment. Depending on the development environment and version control software, consecutive revision control directories may be located in the same path. In web development, even if access controls are used, like .htaccess, during synchronization, the revision control files may be visible momentarily before the .htaccess file is processed. How can you mitigate this? First, do not synchronize directly to a production system. Synchronize to a non-production system and only deploy finalized content. Second, in the case of server administration, utilize virtualization to prevent unnecessary downtime. Last, for embedded or desktop items, only propagate essential system operation components. Then, examine the system for remnant revision control and source code data. When using installers, new content is extracted to a deliverable system. Often the executable and/or archive file that contained the content is left behind. In the case of web server administration and development, while content is unpacked on a production server, the archive may be momentarily accessible. How can you mitigate this? First, before you deploy a system, remove any archives used to install or extract new content. The archive can be reused or repurposed for exploits. Second, on web servers, unpack content outside of the production environment content area. And, similar to revision control, only bring final content to production. Leaving non-essential, old, and/or backup files on a system is a prime example of creating DOE content. Often these files may appear with .back or .orig or .old appended to their names. On occasion, the development environment may do this automatically, like Emacs adding .html tilde. In the worst case, appending file names will make plain text source code files obvious and available. For example, .php files render in a text editor as opposed to executing. How can you mitigate this? Make backups in your development system environment. Always remove backups or non-essential files from a deliverable system. Also, make sure your development environment or editor does not append file names automatically. If paths are visible to users and access and authorization controls are not implemented properly, then traversing paths may be possible. For web applications, if an index file is available in a web content directory, then directory indexing is possible. How can you mitigate this? Do not store secret content in globally accessible locations. Use access and authorization controls to limit directory access. If a folder is intended only for a specific user, then apply file permissions, limit access by user or user group, and apply password protection. For a web application or on a web server, disable directory indexing. This includes index.php, index.html, home.html, etc. Often, content is retrieved using identifiers. Identifiers can be guessed and tried by hackers. An example of this is logins that render URLs with /homescreen.php, UID equals 9025123. Curious users might try 9025124 and 9025125 and 126 and so on. Traversal is possible for more than just files and folders. Database-driven apps use it too, and many embedded systems also use simple numeric values to identify content. How can you mitigate this? First, validate user input. Make the application manage the session and use access and authorization controls before delivering requested records. Second, do not display parameters if possible. If it is unavoidable, use minimum 8-character alphanumeric strings. Include special characters as well as randomized and salted values. Error messages can also provide information beneficial to crafting exploits. Someone looking to compromise the security of a system will attempt to generate exceptions and error messages. They hope to find execution logic or paths or other DOE content. How can you mitigate this? Disable automatic detailed error messages that contain stack traces or anything that displays source code line numbers. In embedded or desktop items, code comments may be contained in application scripts or configuration files. In web platforms, this may be in HTML or JavaScript. How can you mitigate this? Comments should not contain sensitive information, such as to-do or fix-me lists, usernames and passwords, software version information, developer names and email addresses, and references to internal networks or machines. Make sure your code comments are not accessible to end users. Consider scrubbing comments before deploying the deliverable. For desktop and embedded systems, developers may create hidden user interface components or keystrokes to enable debugging. For web applications, hidden tags are not hidden, and they are changeable. Hidden tags are not a secure way to pass information between requests. How can you mitigate this? Do not include hidden tags that toggle dangerous functionality, for example, debugging. Do not use hidden tags to track sensitive information. Track sensitive information, such as usernames and passwords, on the server side whenever possible. Encrypting hidden fields is not a suitable measure because encryption does not make them tamper-proof. Validate input from hidden fields whenever they are used. And in general, avoid using hidden fields and functions altogether. In most cases, these can be replaced by information that is stored server-wide. Be aware of the presence of sensitive data in content. Many systems are delivered with default credentials that are never changed before deployment. Private encryption keys in downloadable content defeats the whole purpose of a private key. Flash content can be decompiled. In fact, most binary content can be reverse engineered to retrieve passwords or other secrets. So how can you mitigate this? Auto-generate passwords and prompt the user to change their password after the first login. Remember, obfuscation is not the answer, designed so that obscure secrets are not needed. Security by obscurity does not work and can be exploited. On web servers, keep private keys server-wide. Apply file permissions to restrict access, and do not store anything sensitive in the web content area. Encrypt compiled content whenever possible. This prevents the use of decompilers to acquire source code or execution logic. Do not use command shell switches and parameters if possible. How can we detect common DOE content? White box testing is an ideal opportunity to detect DOE. Study your team's development and deployment documentation and processes. Examine vendor and third-party software documentation and processes. Look for potential default, obscure, or hidden content. Search for troublesome files like configurations, source code, and/or documentation. Search URLs and scripts for content that can be traversed or indexed. Find and review all .back and ~backup files. Find and review all HTML comments at once by searching the source tree for open bracket, exclamation point, dash dash, and look for the use of open bracket, input type equals, open quote, hidden, close quote, close bracket. In web pages, black box testing is another opportunity to detect DOE. Use scanning tools such as AppScan, Nessus, OpenVAS, etc. to detect default, obscure, and hidden content types that have known vulnerabilities. Vulnerability scanners provide common vulnerability scoring system values for prioritizing, vulnerability descriptions, common vulnerability enumeration values for searching more information, and resolution methods. Functional testers can perform negative testing, attempt to cause error messages, and attempt to access other records in order to find DOE. In conclusion, default, hidden, and obscure content leads to DOE. To avoid problems, expose the minimum necessary privilege on a system. Minimize the attack surface and do not trust user or client-side input. Mitigate the risks through design, implementation, and deployment strategies, as well as code review, comment scrub, and testing strategies. Use scanning tools to provide a baseline of DOE content checks. Remember that obscurity is not the solution. If the content is available, then attackers can and will find a way to exploit it. And finally, content that is not intended for end users or customers should either be eliminated from a production system or have proper access and authorization controls.